Okay. Where do we leave off here? We have these short little trace that reproduces a bug. And every instruction is required for this. So, and it's the last instruction that is, or last memory access that is the problem. So I think what I'll do now is just make sure there's no jobs running, vim up, csim.c, and what we're gonna do is we're just output a bunch of debugging information to trace exactly what's happening here, because the last thing, it should be a hit, but we're getting a miss eviction. So let's go ahead and look through that. So let's go ahead and run it, csim, but we're gonna run it like this, but without the redirection. Okay. So the miss makes total sense. And then 70, so these are the three axes for the thing. So 70 hits, it goes into the cache. These things miss, so miss, hit. That totally makes sense. So we have 4 things in the cache now. We get a hit. We have C70 here, which isn't in the cache. So that's an eviction. And then a 570 here. So basically we evicted our own, we evicted based on most recently used instead of least recently used, apparently, according to this trace. So let's look through the code. Maybe we can just detect why that would be. So how many sets do we have? Are these all in the same set? Let's print out the set, and that would be where, down here? Yeah, we'll just print out the whole parse of the adder. Make and rerun. So our set is 777. All these are in set 7, with different tags, obviously. The block isn't really important because we're guaranteed for it to be aligned. So we know that everything is aligned to, or sorry, everything is in set 7. So how could we possibly get the situation where we get an eviction? So when we evict, what do we do with the thing? So we got a hit. It should now be in the cache. This thing evicted it though. That's the problem. This thing evicted this hit. So see, oh, what was that? It's my signal. Give me 1 second here.
On Steam.
All right. Okay, so we go in. Where's our eviction stuff? Upsert line. So here's the problem here. So we should have gotten a miss eviction, but evicted the right thing. So our computation of what LRU is wrong. So we have LRU and LRU use. What are these two things? I need to document these better. LRU. Use is line use. Okay, that makes sense. So LRU is going to be the index of the least recently used line. Value of the L lines use. So we go and we say, okay, the use is going to be 0. And -1 here. So I think what I need to do is print out the state when we're doing an eviction. So for int, or say auto I is equal to 0. So 0, I is less than s lines per set, and then I plus plus. So this is going to take us through all of the elements of this set, and then we're going to say printf verbose, and then this is going to be like evicting LRU. I think what I'll do is I'll rename this to be LRU IDX. So code rename. Sorry, I can't do that because it's not compiling probably. So go back up here, say, hey, code rename LRU IDX. And then down here, evicting, we'll just say evicting, new line. And then here we'll say LRU IDX is equal to %d, and we'll put LRU IDX in there, and then do something similar here, which is LRU use, %d, LRU use, and then in here we're going to do something similar here, but it's going to be I, or we'll say lines sub I, and then in here we're going to say lines sub I dot use, and then this will be lines sub I dot use. Is that not correct? Subscripted lines sub I that should give us back a line, right? Yeah. And then I can say dot use. And use is, here, let me just full screen this. Oops. Full screen this. It says subscripted value, not an array, pointer, or vector. Oh, I need to do S lines. And then we need to pass an I here as well. Yeah. And then maybe this is a long. Yeah. And we got our new line. Looks good. Alright, let's get out of full screen here. We'll do our make. Rerun our simulator. So this evicting here, we should be evicting something other than 570, but we decide to evict 570. Do we have the adder in the line? I don't think so. It's valid use tag. We need to emit the tag. So we'll say lines sub LRU IDX dot tag is going to be exactly that. And I think it might be a long. Like that. And then this needs to be S, like that. Okay. Make. And we want to print it as hex, which would be X, I think. LX. Okay. So we are evicting this guy. So our tag, our set is for, but bits are 4. So our tag is everything but that, which makes sense. So it means that we have 2 nibbles chopped off there. So 05, we got a hit, but then we evicted it. We should be evicting like something else. I think we need to increment the use when we have a hit, which we do here. We say, hey, it was used. So 0, 1, 2, 3. Wait a minute. Why is it 1? It should be 2, right? We should, after our upsert, we should print the state here. Can I say print state? No, print verbose. And we'll say S. ET is set. Print verbose. Oh. Yeah, we'll just go to definition on set here. Sorry, up here. We'll copy this down here. Where are we at? Where are we at? Here we go. Oh wait, print verbose is above this? Is below this? No way. Print F, verbose. Okay, okay. Sorry, I was just a little bit confused there. Okay, so this is going to be state. We'll say set state. And this is going to be a set what? It doesn't have its IDX, so this will need to be set. We don't need any of that, I don't think, right? Yeah. Set state, we grab each, we say auto L is equal to, this needs to be fixed there. Set lines sub I. So here we're gonna have to print out some of the other state here. So set state, we're gonna say, hey, your use is gonna be percent. This be set use, and your lines per set are going to be constant. You don't really need that. So we select our line, and we'll say, okay, lines IDX. We don't really need this. Lines IDX use And we'll have tag. I think that's all that's in the line that we care about, right? Yeah, because valid is not really super important. We'll take valid. Why not? Use tag valid. Okay, let's put that in. Make. Oops. Auto L. Sorry, this needs to be L. Well, you can just delete that. Fine, we don't need that anymore. And what does this thing complain about? Oh, it's sim. It needs set here. Okay, set. Come on, bro. Over here, make LD on valid, because valid's a boolean. We could probably just do B. Okay. So we have this load. Everything's invalid except the last one. We insert in the last position. That's good. And then the tag we need to print has hex. Okay, so that's our important guy. He's going in last, 6, 8, A. So now everything's valid. We have a full cache at this point here. We have a full. Can I just do less on this because tmux not great? Okay. So at this point here, we have a full cache. This is not full because we have one spot left. So we have a full cache at this point. And then we take another miss. And then this is where... Oh, no. Wait, what? Let's go back at the top. Okay. So we're saying, hey, do this operation. This is your state after the operation. And it was a miss. Okay. So here we had a miss, a fourth miss. The state's what we expect it to be. And then here we have a hit because they're accessing 70. It's in there. Great. But we don't increment our use. We incremented the use of the ones previous to it. 1, 2, 3, 4. Oh, no, we didn't increment anything. So on our hit, we need to... Yeah, okay. So that is definitely a bug. And what is our state for our uses at 5? Yeah. So use did get incremented, but it didn't get assigned into. That is weird. So we had a hit here. So we went down this path. Oh, it's because we made a copy of the line. Damn it. Can I get a pointer to that? Line valid, line tag, line use. There we go. Okay. It should fix it, right? Make. Yep. Well, let's do our deltas here. So comment that out and comment out this stuff here. Make. Sorry. There we go. And if we go up here and rerun this, no delta. Nice. So now if we rerun our test that we had here, which I forget what the name of it is, but I think it's test csum. It looks like we got all the points this time. And if we run our thing here on the long. It's a test. We're going to go long test long. That's the same as well. Okay. So that was a bug in pretty common bug where we have a copy. So what's the important lesson here is, like, if you want to mutate the actual structure, you need to take a pointer to it. You can't take a copy of it. And I took a copy of the entire line. The line got copied, the entire struct, all of it got copied into here. Where is it being referenced? I can then update. Yep. So my algorithm was correct. It was just the way I was like referencing memory was wrong. It's easy to take copies when you don't think you are copying. And I just did that for convenience, to have like a convenient little way of expressing that whole thing. That is interesting. That is very interesting that this expression s lines sub I dot use, this doesn't make a copy. Whereas that as x and then x dot use, you would think those are equivalent because x is this sub expression. But when you assign it, it makes a copy. That is the key insight here, is that assignment implies copying. So here we're saying, hey, take S, which is a pointer, dereference it, access the member of that like go to that place in memory. So S is just a pointer. It's a 8 byte pointer. And what we're saying, what do we want to do with that? So we want to interpret that as a pointer, go to that memory location. Okay, now we're there. Now go to the lines field of that struct, and then we're going to basically perform pointer arithmetic. So go ith elements into that array, and then I think this implies a dereferencing, right? Yeah. So we're at the ith element of the array, and now we're saying go to the use field of there and then assign it to 5. Versus this is saying, okay, we have our pointer. We're going to go to that memory location. We're going to access, this thing here. We're going to access the lines field. We're going to go ith elements into that array. And then the assignment comes in and is saying, now take a copy of that and assign it into the local into the stack. So now you have a copy of lines on the stack, and now you're mutating that copy. So it's a bit of a thing that you need to watch out for with C. I mean, the same thing applies in Go. Like Go, you would have the same behavior. And in fact, I've run into this bug like a billion times in Go as well. In that assignment implies copying. You're doing some type of copy versus just accessing the memory in place in situ. So I think that's the important thing that I need to make sure to get into my brain when I'm doing this type of stuff, is that you can't just alias stuff by reference by taking a local variable, because that local variable, even if it's a structure, it'll be a copy. I mean, if it's a structure, if it's a pointer, if it's anything, it's gonna be a copy. But with a pointer, you typically dereference those pointers, and so you're not copying the thing that's being pointed at. you're copying the pointer itself. So just something to keep in mind. Okay, so we're good. We're good. Get at all, get DC. And I'm gonna move this this traces. Actually, CD into traces. Move test into bug.trace. And this is all to help solve that bug. We can take out some of this stuff like access sequence. That's just good for instrumentation. And the additional adder here, we're not using that. The size we'll leave. I think that was a good improvement. We'll delete this and this. This thing will remove as well. Okay, we'll rerun our little test here. This time, yeah, that's good. Get at all, get DC. So this function was just to get a character based on its type. That's fine. That was just adding some comments and changing variable names. This is the actual fix for the bug, which is to take a reference instead of a copy. That's the same. That's the same as just dereferencing. We have to dereference everywhere, and the change in the variable names. This was some printlning or printf verbose just to like print out state. Same thing with that. That is actually something that is needed for the delta. Load takes into size now, some comments, some debug stuff that we don't need to have uncommented. Load takes into size, store takes into size. We change our printf verbose, passing in size into the load and stores. Again, more matching the output of the existing program. rmref.txt and rmtest.txt can both go. Wait a minute. Sorry, I meant to do this. Okay. There we go. So we're done reviewing the code, and that was just a little test case. Okay, get at all, get status, get CIM, fix bug with use not being incremented. Correctly. Okay. So that finishes that part of the problem. Let's get out of full screen mode here. We can move on to part B. So, optimizing matrix transpose. In part B, you will write a transpose function trans.c that causes a few cache misses as possible. Let A denote a matrix, and Aij denote the component of the ith row and jth column. The transpose of A is denoted AT, is the matrix such that Aji is equal to A transpose. Aij is equal to A transpose Ji. So just swapping the columns and the rows. To help you get started, we have given you an example transpose function in trans.c that computes the transpose of n by m matrix A and stores the result in m by n matrix B. So character array, trans description, simple row-wise trans scan transpose, trans int m and int n. Yeah. And then we have A is nm and B is mn. The example transpose function is correct, but it is inefficient because the access pattern results in relatively many cache misses. Your job in part B is to write a similar function called transpose submit that minimizes the number of cache misses across different size matrices. Same prototype. Do not change the description for your transpose submit function. The autograder searches for the string to determine which transpose function to evaluate for credit. Program rules for part B. Your code in trans.c must compile without. You are allowed to define at most 12 local variables of type int per transpose function. The reason for this restriction is that our test code is not able to count references to the stack. 12 local variables of type int. We want you to limit your references to the stack and focus on the access patterns of the source and destination array. You're not allowed to sidestep the previous rule by using any variables of type long or by using any bit tricks to store more than one value in a single variable. Your transpose function may not use recursion. Interesting. Has to be an iterative solution. If you choose to use helper functions, you may not have more than 12 local variables on the stack at a time between your helper functions and your top level transpose function. For example, if you transpose declares 8 variables and then you call a function which uses 4 variables, which calls another function that uses 2 variables, well, that's like 14. Yeah, you'll have 14 variables on the stack and you will be in violation of the rule. Your transpose function may not modify array A. You may, however, do whatever you want with the contents of array B. Well, that's the whole point, right? We want to transpose into B. You're not allowed to define any arrays in your code or use any variants of malloc. Okay. Evaluation. So I think I got all the 27 points on that CSIM, test CSIM. Yeah. Evaluation for part A. For part A, you will run your cache simulator using different cache parameters and traces. There are 8 test cases, each worth 3 points, except for the last case, which is worth 6 points. You can use the reference simulator to obtain the correct answer for each test case. During debugging, use the B option, detailed record each. Yeah. For each test case, outputting the correct number of cache hits, misses, and evictions will give you full credit for that test case. Each of your reported number of hits, misses, and evictions is worth 1/3 of the credit for that case. That is, if a particular case is worth 3 points and your simulator outputs the correct number of hits and misses, but reports the wrong number of evictions. Okay, evaluation for part B. By your correctness and performance of your transpose submit function on 3 different sized output matrices. So you get performance is 26 points. That's like the whole thing, right? But if it's not correct, you get no points. For each matrix size, the performance of your transpose submit function is evaluated by using Valgrind to extract the address trace for your function and then using the reference simulator to replay this trace on a cache with parameters S5E1B5. Your performance score for each matrix size scales linearly with a number of misses, M, up to some threshold. Your code must be correct to receive any performance points for a particular size. Your code only needs to be correct for these three cases, and you can optimize it specifically for these three cases. In particular, it is perfectly okay for your function to explicitly check for input sizes and implement separate code optimized for each case. I don't think I'll be doing that because I want to keep it generic. Evaluation for style, there are 7 points for coding style. These will be assigned manually by the course staff. Style guidelines can be found on the course website. The course staff will inspect your code in Part B for illegal arrays and excessive local variables. Working on the lab, we're already done with Part A. Alrighty. Let's go ahead and run the test trans. M10 N5. Validating the general and generating memory traces. Validation error at function. Skipping performance values. What's going on here? Okay. Can I just call into return, or I just call trans of M, N, A, and B. Call it a day. Make plus the declaration of trans. Oh. Okay. Well, I just want to do this to do a forward declaration. Can I do it like this? Is that valid syntax in C? Probably not. So back out of that, do it like that. Sorry, void. Okay, it compiles. I think I can get it to go here if I wrap this in parentheses and then call it like this. But instead of saying trans, I think we leave this off, right? T. Okay. Well, let's run our test trans. Hits, misses, evictions. Some correctness 1, misses 35. Okay. So let's not call that. And we'll implement our own. So this is going over A. We're going over both matrices and row order. Row major order. I mean, it's pretty efficient already if it's doing that. You don't need that temporary variable. A temp is not necessary because you can read from one memory address and write to the other. That might be an optimization for the cache though, maybe. So let's open up Excalidraw here. I'm gonna send you to 5 for now, or maybe 4. Send you to 4. All right, and here let's go ahead and create a matrix. So I'll just do like a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And some of these, I think I need to make this a little bit more of like code-like. And these need to be spaced appropriately. Okay. So that's your matrix. Let's go ahead and blow it up a little bit. So to transpose, we're reading values here and writing them here. So we're writing them blowing through the cache lines. So say our cache line is 2. We can fit 2 things. or say it's 4. So our reads are hitting the cache, but our writes would be, and I should probably fix this up a little bit to be more like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So our reads are going to be like that, but then our writes are going to be this guy here. And if our cache lines are, say, 4, then our writes are going to be hitting a separate cache line each time. So as the matrix gets bigger, our writes are going to be just like, what do they call it? They're going to be, the stride is going to be the size of a row. So the idea is that, like, if we can focus on a subset and transpose it, and then move on to a separate subset that's local, then maybe we could have better cache access. So the idea would be, like, if we could do an access like this, where we take these and transpose them, so they would be transposed of themselves, but maybe like we move on to this and it would be transposed with this one over here. So that wouldn't be great. But let's go and implement. That's what they're telling us to implement. So what sizes are we gonna be testing on? I guess it should be generic enough to where it doesn't matter. So we need to handle remainder. M is the width. It doesn't matter. But M would be the, no, sorry, N is the width. So let's take N divide by 4, and we'll say width auto if width is less than 2, then we want to set it equal to 2. Sorry, this needs to be like that. Width is equal to 2, but only if M, so we just have to say here, and M So basically, if width was computed to be 0 because n is less than 4, or if it was 1 because n is 4, we go to 2. If it's 5, we go to 2. So here, let's do some test cases here. So width would be, say the matrix is a 1 by 1, has a width of 1, then width would be 0. That doesn't work. 2, 3, 4, 5. So this first expression here will give us 0, 0, 0. 4 would be 1, 1. And we want to turn this into at least, we should keep on going here too. So this will be 6, 7, 8, 2. I think we need to say if width is less than 2, then we say width plus plus. So I turn this into a 1, 1, 1, 2, 2, 2, 2, and then we stay with 2. And I think that would even, yeah, okay. We'd have a remainder. There's going to be a remainder here. We're not going to have any remainders through here because it's one element. But 5, 6, 7 will have remainders. Oops. And if we had a 9 here, be 2, 2 with a remainder. I think that works. And we'll do the same thing for height. M divided by 4. And if height and we can fix this up to be like that. I'm gonna have to have these breeze. I like doing it like that, but the Klein formatter doesn't like that. Okay, so that gives us our thing, but we might have remainders. We'll just say to do handle remainders. Do all that. Okay. Okay. So what we want to do is we want to handle each cell like this. You want to compute this and where it would go. Oops. Why is this thing so hard to grab? We're going to send you to the back. Okay. So this goes to that. Then we move on. Oops. You need to go to the back too. This goes down here. Oops. This would go up to here. And this would go down to here. We need an expression to calculate a positions transpose based on the matrix size. And the original form, or the original algorithm, basically switched I and J. So if this is okay, I think that's fine. We don't need any temporary variables for that. So n mod transpose size will give you how many iterations that we need to do. So that's how many chunks that we're going to have horizontally. And then same thing, J here. Oops. So this needs to be I plus plus, J plus plus, J is less than M. And in here, for auto K is equal to 0, K is less than transpiz size. Can we do a code rename on that? No. Maybe if I say K plus plus here, put a semicolon on it, write it, and do a code rename on that now. Code rename, no? Okay, well, transpose size. Oops. L, L, L. Okay. So transfer size doesn't have to be a constant. We can make that variable, but just for the sake of proving the concept, I want to make it a constant for now. So in here, it's going to be A sub I times transpose size plus K sub J times transpose size plus L. All of that is equal to, assigned into is copied to the inverse in B, which would be here. Oops, I'll just do this. Alright, let's go ahead and make that. And we'll rerun the test to make sure it's correct. Correctness is 0. Okay. Well, what we'll do is we'll print out, call it print. Is there a print result already? Print matrix. We'll give it A and B. And we'll go up here and we're just going to say void print matrix. Matrix is int m, same. Like this. And we'll do nm. I feel like that makes more sense here. A is n m a, B will be m n b. Okay. Then here we say for auto I is equal to 0, I is less than n, I plus plus. This would be J is less than M, J plus plus. Let's say printf out n size is dxd. Can I do that like that? New, we do colon, new line, n and m. And then here we say printf out space percent d, and this is going to be without a new line, and it's going to be a I j, and at the end of every one of these rows, so j is being iterated through the row, we're going to say, hey, printf the new line. And then we'll do the same thing after all the columns. We'll do another new line. Just make sure there's some space there. So make trans. Where does that get output to? Oh, it's a trans O. Trans C gets compiled into trans O. Trans O goes into test trans. Okay. Test trans. Oh, it's because it's not an even. If we did 8 by like 8 here, I bet you it would work. No? Isn't that fascinating? I can't even exit. If I can't exit, what the fuck is this trace gen? Okay, that's the problem. Vim, oops, please go away. Okay, that goes into test trans. It also goes into trace gen. So I'm guessing this thing only uses it as a precondition to recompile, whereas trace gen actually needs it. So let's run trace gen. I don't know what F0 is. Okay, we got an exit status. If I echo out, there we go. We got our 1, 2, 3. So now if I do that and do a make, and then do that, it'll actually give me the matrices here. Let's do it a little smaller. Let's do maybe a 2 by 2. Okay, that failed. So I was thinking maybe let's do a 4 by 4. Okay, 206 did not go down there. Wow, everything's just fucked up on this. So 30, 96 went where? Here, and before we do that, we'll say printf. Oops, up here. Percent. We'll say I. If we just did this, we should get all zeros, right? Make. Just want to assert that. No, we don't get all zeros because B isn't properly initialized. 36, 83. No. Boyo boyo. The problem is that we're doing nothing and we get garbage out in B. Okay. I don't know how big of a problem that is. It just means that they're not initializing the memory. Okay, so we're moving I, J, D, D, to, okay, so new line here, and it's gonna be moving this, comma that, to this, comma that. Okay, let's do a make, run. It didn't even say that it's doing in the moving. Let's do a quick printf here. We'll say width is equal to %d height okay. Let's do a make trace gen 2x2, but we got no printout. So I is equals to I is less than n mod transpose size. Transpose size is 4. N would be 4, right? So that should come out as 1. It's actually going to be n mod width here anyways. This is going to be n mod height. And we probably have a precedence issue here. So let's get out full screen, see precedence table. So we're using mod, which is here, and then relational operators are lower precedence, so we don't need to force the precedence. Okay, that's good to know. So our width and height are both 2. Okay. Sorry, I had an extra parentheses there. Make trace gen. That's the reason why we're not iterating. So n, which is 4, modded with the width, which is 2. So we need to divide here, not mod. we go. Still the wrong output, but we can go through and say 0, 0, 0, 1 is going to 1, 0, 2, 3. See, B10, B10. It should have been moved here. Moving 0, 1 to 1, 0. Moving 0, 1 to 1, 0. The problem here is it's transposing it multiple times. We should only have 16 different operations. This is way more than 16. We should be done here. So %d cross %d, we'll say n and m here, n, m, we'll say I and j. I think this needs to be width and height. And then these need to be I times width, height here, height, width. This will be width, height, height, width. Okay. Make. Hey, look at that. We got it. Okay. I don't know what this dash F is for, but I want to go to a 9, or let's do like a 2x2. Make sure it's still correct on 2x2. Okay, that works. If we do a 3x2. Well, if we do a 4x2. Ah. So width is 1 and height is 2. We need to put a new line here. We'll say batch. make. So we got 4 batches of 2 by 1. This is going 1 by 1. That's wrong. Something went wrong here. We are iterating through the batches correctly, so this logic is correct. But something's going wrong here, where we should have a third element here. So KL, 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 plus plus 0. We're not modifying anything. Why is the height? Oh, the height is still 2. It's width 1, height 2. When this needs to be width 1, height 3. No. Width 1, height 2 is correct. A 4 by 2 height should probably be a 1 too. Let's log out the pre-height here. So this is going to be pre-width and pre-height. Make. So pre-width is 0, pre-height is 1. So that turns into 1, 2. Why is pre-height 1? N is 2. I'm going over A. N is 2. Okay, so width should be 2. I'm confused here. We have a... yeah, this is the confusing part. It says size 2 by 4, and it's a 4 by 2. And then 4 by 2 is a 2 by 4 here. So in M and N, so A is N, M says width and height. That's correct for A. And then where do we print out these dimensions again? So size gets its dimensions, N and M provided directly. So A does not have N and M, it has M and N. and this will be N and M on B. So let's make that, trace gen it. Okay, that makes a lot more sense. So width now is 1 and height is 2. Okay, that makes a lot more sense. So we first have 0, 0 going to 0, 0, and then 0, 1 going to 1, 0. So if we look 0, 1, which is this value here, we should print out the values too. Alright, make, and then of course we need less new lines. I don't know why I added a new line there. Okay, so we have 0, 0, the 36 is going to 0, yeah, and then 0, 1, which is 91, going to 1, 0. It didn't get there. We need to zero everything out up front in B. Well, let's do it for debugging. So I can't freaking deal with all these random values. Okay, it doesn't matter. B I J is equal to 0. We'll do -1 here. And then we're going to comment out all of this. And we're going to make it. And we should have -1 everywhere. We don't. See, this is the problem. We wrote -1 everywhere and there's still data there. So we're going over I. I is less than N. Okay, so if we're going to iterate over that, we should go over M here. N. Make. Doesn't matter. So something's wrong with our printing out here. N and M. B is MN. Wait a minute. I think it was right here. So fascinating. So we say M and N, L, M, N. So M is really the width of B. And we have it inverted to where N is the width of A. So if we did this here, we say, hey, A, and of course we're going to switch N and M here. And we'll say -2 here. Did that print everything out? Make. Yeah. But we're not a 4x2, we're a 2x4. So that's a problem. I think it's the same amount of memory writes, but it's the way it's being displayed is weird. I would like to say NM here, but I wonder if that's correct. So M is the width, M and N. Why is it that when we cross these and say, before we had MN, if we do NM here, why does it give us weird values? Shouldn't do that, right? Okay. And then N, M, and N here. Seems weird to do it that way. So M is the width. Let's document this. M is the width of B. N is the height of B. Which means M is the height of A. N is the width of A. M and N. N and M, M and M. 4x2. It should be like this. And then when we print our matrix, we're saying, hey, your width is N and your height is M. So 4x2. Oh, but we switched it here. That's why. M and N here. M and N there. M is width, N is height. Yep, and then these need to be switched as well. I, J, and I, and J. Make. So that gave us an invalid access on the output. Fascinating. Okay, so you want to keep consistent M and N, M and N, M and N, N and M on A, because that's reversed. And we want to say it is a M by N output. Make 4x2. So the iteration here is somewhat incorrect. So we're saying, hey, okay, I is going to be everything less than M. So we should be going 4 here on I. And then in here, for every J, J should be going 2. because it's 4 by 2. No. This is handling one row. This is handling every element of the row. Okay. Why is this so hard? Shouldn't be this hard. I'm not thinking clearly about this. So we have a 4 by 2. That means there's 2 rows. That means I needs to be n. Because you're going over how many rows. And j needs to be m because that's how many columns there are. Yes. That makes sense. Okay, that's correct. 2 by 4, 4 by 2. Okay, we got our printing right. We got our printing and our initialization right. Although I worry about the initialization. So here we're saying go over I is less than m. So again, m is going to be our width. So it's going to be handling every row and then every column. And it's going to be handling every n, which is columns in there. Yeah, okay, this is correct initialization. Okay. So m is the height of A, n is the width of A. So, okay, that's correct down there. Initial for debugging. Okay. There we go. So now if we make here, oh, I want to do the other one. This one here. Not A, but B. There we go. Okay, there we go. All right, so now we computed our pre-width, which should be 1, or 0, and then width is 1, and our height should be 2, and our pre-height was 1. Okay, that's fine. Looks good. So now, what does this do? So we have, let's iterate over batches of that size. The batches seem to be perfect. So let's go ahead and make this. Okay, and our axes are wrong here. So we're handling batch 0, 0, and it's a width 1, height 2. So it should be 26 and 35, yeah. 26 landed correctly, 35 did not. So we're trying to go to 1, 0 on the yeah. Wait a minute. Size is height, width is 1, height is 2. 26, 35, yeah. Which is 0, 0, 0, 1. I think that's incorrect. It'd be 1, 0. Because they're dealing with rows here. So all of that is wrong. Okay, so let's try to calculate this again. So this would be a row and a col. So a row is going to be equal to the ith element No. It's going to be equal to j times height plus, and this would be L, and the column will be equal to we might have things fucked up here. I think that is wrong. I think this needs to be I, and this needs to be J here. I, J, I, J. Let's try that. Still wrong. Okay, so we're going over, we want to go over each batch, and we're able to iterate through those batches. 0, 0, 0, 1. And it's going to be row, I think we're iterating correctly. We were iterating correctly before. M, if we go back up here, it's the height. N is the width. Okay, so let's compute these values here. Auto A row is equal to 0, and oops, it's equal to 0, and B row is equal to 0, or B col, sorry, col. A col, a row. A row, a col. This would be a row, a col, B row, B col. Then we read the value, and then we do the same thing here. B col, so B row, B col, A row, A col. Okay. So A row will be, so M is the amount of rows in A. So M divided by the height will give us the number of batches, row batches. And then we add on K. I think K needs to be height here. And then A, this needs to be times height. This needs to be times width. Okay, so we're iterating over I, and it's the amount of rows in A divided by the number of rows that we're iterating over. The number of rows in the cell or batch. So that should give us how many batches. And same thing with the width. So the batching is correct. And then we get to K. K is, we're saying, hey, K is less than width. So we're iterating over K. Sorry, K is less than height. So it's going to be number of rows. And then L is going to be number of column, each individual column. So K will be added on to the height to get the row. And then somehow I reordered these, which made me even more confused. So row is going to be I times the height plus K. Width is going to be the J times the width plus L. And then we invert the column and row for B. Okay. So make. Alright, the result is totally fucked, but batching is still correct. Let's actually make the width even bigger. Let's make it like 8. So it's very clear which way we're iterating. So 0, 1. So it's a width of 1 and a height of 2. Okay, that iteration order on the batches seems fine. Its iteration order on the individual elements is messed up, so zero, 1, or 1, 0. Let's do the same thing for A here. A, and we're going to say num. We're going to say int num is equal to 0. And we'll say post increment here. Fuck it, we'll do a pre increment, why not? These need to be inverted here to be n by m. So 1 and 3. 0, 1 is going to 0, 0, yeah. And then 1, 0. Look at this. It's insane. That's totally wrong. Why is 1, 0 in A pulling out 9? The A row thing is just like, it's rows and columns, but my brain is messed up because I'm viewing it as X, Y. So we gotta treat this as rows and columns. So row 0, column 0, obviously 1. Row 1, column 0, because the width is 1, is 3. How do we not read out 3? How do we not read out 3 there? It's row 1, column 0, and we read out 9. Which would be row 5, column 0. We added 4 on there somehow. These are all ints, right? Int and int. Can even auto this. Oh, damn it, man. This type of iteration shouldn't be this hard. I just don't understand how accessing row 1, column 0 would give you 9. That's row 5, column 0. And then go down here, it's like, okay, 2, 10, and now we're off into the universe down here. It just doesn't make any sense whatsoever. That we read 9 there. It doesn't. In no universe does accessing that make sense. Okay, well, when we're initializing B, can we just say like here, printf, sorry, we're initializing A, we'll say printf, and here we'll say A sub I, say %D sub J, %D is equal to %D new line. And this is going to be I, J, and then A sub I and J. There you go. Make. Okay. So here, 1, 0, which is row 1, column 0, which would be 3. It's 9? How? M is what? M is 8? Let's print out up here. %D x %D. And this is going to be M by N. Make. Okay, so we have an 8 by 2 for our output. So that means 8 by 2. If I zero out all of this stuff here, and we just print out the matrices after they're initialized, everything's looks right from the output, 2 by 8, 8 by 2. But the access here, we're accessing it incorrectly here. We're going 8 elements. A is an n by m. B is an m by n. So this is n. M is rows. Ah, fuck, man. This is so annoying. I might just take a break. B, which is our output, has m by n dimensions. M is, and B should be, the number of rows in B. M is 8. I think that's my problem. Is I keep on thinking of it as number of rows when really it's number of columns as a width, when really it's number of rows. Rows by columns. That's the way I need to think of it. Rows by columns instead of width by height. Okay, so let's go back up to our printing here. So we have rows by columns, and then this needs to be m by n. Rows by columns. That's just it. And we're going to go I, J, I, J, I, J. Rows by columns, rows by columns, rows by columns. Eight rows by 2 columns. 2 rows by 8 columns. Just the way it is. 2 rows by 8 columns. Okay. Alright. So now we understand. Rows by columns, m, n, rows, columns of the output. Okay. So to convert that into, now we're iterating over the inputs into the output. So that's why we're going to say batch width. And then height. Batch height. Okay. So let's make sure those numbers are correct. So so our batch width for this should be 4. With, why is it called width? Batch width. Width. We're going to change this up to, instead of saying batch width, we're going to say batch rows. Because if you look at width, width is the number of rows of the input. Wait a minute. 1 by 2. We need to zero pad these anyways. So when we're outputting the print thing here, say 2D. Make, there we go. 1 by 2. 6, 7, 8. That'd be 8. Should it be 2 by 2? 1, 2, 3, 4. I'm just going to delete all this. It's not even a transfer size. It is, let's call this batch. Components. We're going to try to decompose it by 4 elements. So we say, hey, take M divided by 4. So now we have 4. And if... So M is always going to be greater than that. So this isn't the correct thing. So if I have like 16, I want to go down to 4. But if I just have 4, I want it to be 1. So I think I have to say batch components here. Which limits it to be... Let's just define another dimension here. Min size is 2. Min batch size. So you say, hey, you got maximum between the components or the batch size. And then, so that's going to be our desired batch size. But if that is greater than or M, then we want to just be M. So if you have a really large number, we get down to batch components, there's pretty small pretty large numbers still, and it's greater than that, and it's less than M. Now if we have a very small value, divided by batch component, it's going to be another small value. The min batch size is going to bring it up, But then if that's larger than m, it gets back down to m. Now in the middle, so I think I have to do this little dance here. Cols. So this will be n. So we need to implement min, and we'll just add them up here. Int min, int a and int b will give you return a is less than b, then we return a, otherwise return b, and then same thing here. And if you didn't want this to be a function call, you could inline it, or you could do it as a macro. But sorry, if a is less than b, return b, otherwise return a. Alright, and this needs to be called max. Okay, great. So we'll just do a make here. Wait a minute. Okay, so we have our rows and columns, but this is more like our batch row. Batch rows, batch calls. Okay, now we go into this and we say, hey, we're going over m. I don't think that's correct. Because batch rows, no. So we're trying to get back into an A mindset from B. So B has M, which is the number of rows in B. And we took that number of rows, we divided by the batch component, so we got this number out, which is a fraction of M. So it makes sense that we would stick with M if we're on the output, which I think fuck it, we'll just do the output iteration. I think trying to go by input iteration is like messing me up here. We'll just iterate over the output. No, we can't do that. We gotta iterate over the input. So input, the number of rows would be n. N number of rows. So I have to prefix this with saying A, in which case this is N and this is M. And of course this is N here. Good thing I caught that. That would have been a bug at the end there. So then we're saying, hey, A batch rows and A, we're dividing our number of rows by M. Okay, we're just going to handle the batching here and make sure the batching is correct. Okay, so we're going to say make, and we'll run it. We'll make sure our batching is correct. So 0, 1, 0, 2, 0, 3, 0, 4. Or sorry, 0, 1, 0, 2, 0, 0, 0, 0, 1, 0, 2, 0, 3. Okay. So we're just going that way and it's going to go down that way. Now to do something else, maybe we do like 16 here. Or sorry, 8 by 8. Let's do an 8 by 8. So that looks correct to me. And then we'll do a 2 by 8 or 1 by 8, say. Yep, that's correct. Okay. So 8 by 2. Now let's go over this. K is less than This is supposed to be row oriented. A Okay, let's try that. That looks correct to me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay, just getting very clear on the terminology and getting my head straight around the order here. That MN is on the output matrix and NM is the input matrix. Just getting that straight, and then also fixing all my printing and everything, I think helped a lot. And then also having a clear picture that it's 2 rows by 8 columns. It's rows columns, not XY. Or width height. So it's a bit of a inverse of what I normally think of when I see this X. So it might even be better to just say like don't even do that. Say like rows by cols, and don't even have that X format. And then when you're printing out these tuples, I think it's fine to have that moving. We'll say A to B. Like that. Sorry. There you go. Rows, columns, rows, columns. And then up here, when we're initializing things, I don't think I need to print that out anymore. Let's try to get something else here, maybe like 16 here. Looks correct. All right, the logic is correct, I think. So all of our printfs, we want to like pound to find them out. So I can say something like printf debug. And then up here, pound define printf debug as, can I just do like a comment? Like something like that. Let's ask ChatGPT, is there a no-op variadic argument function in C? Okay, we can do something like that. Okay, close that out. If I do in here, would that work? Make? Hey, it works. Cool. And then I'm gonna say, hey, trans, was it test trans? Also, what is it called? Test trans. Test trans, and we'll do an 8 by 8, 8 by 2. So it's correct. All right. A lot of work just to get something that's correct when we already had a very simple correct form down here. And then we want to like not initialize A and B. That'd be great. Make. All right, let's do our trace gen. And then we'll say this is going to be just printf. VA args. Make. Okay. So I wanted to do a smaller test now. Let's do like a 2 by 2. Alright, looks great. And then I want to do like something that's like a 3 by 3. 3 by 3. Yeah, so that doesn't work because we're iterating over the cells, but then we have the remaining stuff after the cells, after the batches. So here, we'll say remaining calls is equal to auto, and then mod here. Nine six there, 2 6. So we didn't get to 1 3. So it's the remaining calls here. So we can handle those by just doing extra work at the end of the column loop. Okay, I think we should do that. So remaining calls. For auto RC is equal to 0. Well, we just set equal to this, right? And then we'll say RC minus, like that. And then here, we're going to say, do some of this stuff here. We should pull these things up here. So this has a dependency on I and K. So this should be done up here, along with this one here. And then this has a dependency on J and calls L. So we need to do it on the inside here. Sorry. So here we're saying the remaining columns, we're going to do M mod I'm gonna take a break here. I'm tired of this stuff. To do implement remaining calls rows. I just need to take a break here. My brain's just like not having any of this. It's getting close to lunch here, so we will just take an early break. 12:15. And I'm going to do my little BAM, check mark, button, space, save. Update here. You can move to 12:15. Alright. And then this guy gets an extra 15 minutes. This will be 1:45. And he's going to 5. Boom. All right. That was a good couple hours, I guess, on the transpose thing. To be honest, like, I'm only implementing it this way because of the recitation kind of like hinted that this would be the way to implement a performance improvement. I don't even know if this is like the correct solution for performance. And he also talked about like special casing it for different sizes of matrices to optimize for the benchmark. I'm not going to be doing that. What I will do is change the batch sizing. Because right now I'm taking the whole matrix and I'm dividing it by 4s. So if it's a very large matrix in both dimensions, then you get, instead of the whole matrix, you get 16 or 4 times 4 different sub matrices that you're then dealing with. And what you really want to do is make that width and height of the you really want to make that cell something that fits within your own caches. So I think what I'll have to do is I'll have to run a bunch of tests here and just find what's most optimal sizing wise. Just do my own manual optimization process. But first I have to get it correct on like odd number matrices, odd number of columns and rows. It's kind of silly how long it took me to figure out like the N and M, because in my mind like N is always like the number, the size, so it's always like the first thing in my mind, like the rows, and M is columns, but alphabetically M, L, M, N. M comes before N, so M is the columns, or M is the rows, and N is the columns. And then the fact that there's also switched in up here was messing me up. I think once I got it straight in the printing, it's like M and N, M and N, M and N, M and N. Just very simple outputting. And then also got it straight on rows and calls. That was important as well. So let's fix up this real quick just to have. Well, I don't have any time, but I do want to fix. Where the freak is this thing? Batch. Okay, well the batch is. We'll do it like this, just to signify its rows and columns. And then I was outputting some size before I outputted the actual. Is that up here? Yeah, up here. Okay, so here we need to say rows and calls. Take that out. Make. So it's a 3x2 output, and I really don't need this up here. So it's kind of redundant. Make. So batch 0, 3x2, 3 rows, 2 columns, 2 rows, 3 columns. Okay, alright, I'm gonna hop off here, grab some lunch, and I will be back after I do my cardio. So probably an hour and a half around that time. So 1:45 or 2, something like that. Cool. Alright, be back later. Bye.